I'm Colin Mitchell, and I started a magazine called Talking Electronics. The main point in starting the magazine was to help people actually learn electronics from the very basic levels. And that's the reason why we produced a magazine and provided kits. This was the essential part of the magazine, is to provide a kit for every project we produced. We had a kit to back it up. Everything operated from my home, and it was a mail order business basically. And people could come if they wanted to buy the kits, but most of it was done through the phone and through mail order. We sold over 300,000 kits. When I was about 12 or 14, my auntie, her son was interested in radio and electronics, and he was going to, I think, leave home for some reason, and she gave me all his radio stuff, which was old valves and old radio things, but that was the first time I'd ever handled any electronic components myself. It was given to me. Then I was building a crystal set, and I had the crystal set on the window ledge, and I had a crystal earpiece in it, and I was tinkling around with another crystal earpiece somewhere near the front of the circuit. And all of a sudden, I heard my own voice. And I thought, how can that be? I could hear my own voice. What I'd produced was a tiny little amplifier. And of course, that changed my whole life, because before I was just listening to radio stations. And once I got this little amplifier working, it changed my whole idea of electronics, that I could build something which wasn't just a crystal set. Nobody taught me anything. There was no books around. I had a book on crystal sets and things like that, but you just learn yourself. You use all the equipment you can get in those days. It was basically a multimeter and a very simple crow, but you just learn and learn and learn. And when a thing works, or if it doesn't work, how you can fix it is the most important thing. So what I did is I then produced little amplifiers, and I was using these amplifiers to listen around the room. And I went to Myers, and Myers had a hearing aid section. And I asked them for any old hearing aids. Well, they had a huge box of hearing aids there, all with these tiny little pencil valves in them with 5 little tiny wires out of them, and they worked on a 22.5 volt battery, and some had a 45 volt battery and a 1.5 volt battery for the filament. So I got all these mountains of hearing aids, and I went through them. The valve ones didn't interest me, but down the bottom of this huge number they gave me was some hearing aids that had transistors in them. And in those days, they were the OC transistors, but a miniature version for hearing aids. And they were plug-in. They plugged into the board with a tiny little socket. So now I had a 3 transistor and a 5 transistor hearing aid that worked off a couple of tiny little batteries. And that's where my electronics started, by getting these hearing aids for free from Myers Hearing Aid Service, and I made little amplifiers. So then they turned around and said, well, we've got a new course coming out, which is electrical with electronics. So I said, well, that's for me, because I want to learn electronics. I want to learn about these things. There's new things called these transistors. So I went to RMIT and I learned about the basics of electronics. Well, it was very, very, the minimum amount you could possibly imagine. We had practical work once a week, and it was to do with the theoretical structure of a transistor. There was nothing really associating the transistor device with anything that was available. And I had bought a 6 transistor radio, I don't know if it was a National or a Sony or a Sony. It could have been a Sony 6 transistor radio. But apart from that, that was the only thing that we had in the house that was electronic, which was transistorized in those days. Then I did 15 years of TV service. I think in the early days of electronics, there was a demand for servicing. Even though the radios were a lot cheaper, the ones from Hong Kong and Japan were better. They gave a better quality. They were really a better device. And also the TVs. I sold hundreds and hundreds of colour TVs. We had the Philips TV here, the colour TV. Well, I was absolutely flat out fixing the Philips TV, the Luxor TV, the Finlux TV, Nordmendy, Blaupunkt, Siemens, Graz. All these TVs had basically Philips transistors in them, and they all gave enormous amount of trouble. Well, when the Japanese sets came with the Japanese type of transistor, which had a higher voltage rating, that immediately changed from 2 to 3 jobs per year to no jobs. And of course I could see the business was dying. And that's why I sat down and I said, well look, my business is absolutely disappearing because the sets are becoming so reliable that I had to change into something else. And that was the reason why I turned around and said, well, I'll think of something else. And the concept of talking electronics came along. I had written a magazine when I was about 20 years of age. I was asked to produce a project, a very simple project using a few gates and things like that to control something. I can't remember what it was now. So I made the device, and he wanted a few more made, but he also wanted a description of how the circuit worked so that he could give it to the service people so that if a thing failed, they could service it. So I looked at how the circuit worked, and I had to describe each component. And there was a couple of components that I didn't quite understand as to how they charged, and there was a capacitor there, and how it discharged. I understood how it charged through the resistor, but how did it discharge to create the oscillations, to create the cycle. So I went to McGill's and I bought about $430 worth of books on integrated circuits and designing circuits. And I read through them, and nowhere did they actually describe, they described the oscillator, it was all written there, but they didn't describe how that capacitor discharged. So I turned around and said, well, I've got to actually find out, because I want to describe that part of it. So I had to get my multimeter out, I had to go to all the work of describing how it worked. And I realised that there was a slight void there on, they just very casually went over how circuits work, but didn't actually go into the, because when you ask a question, well, how does this work? It was never ever answered. They just said it oscillates. Well, that's not good enough when you're servicing something, because you want to know what voltage is on these capacitors, you want to know why they're failing or why something's going wrong. So you need to know the intimate reasons as to why something is charging and discharging. So that was the reason why I thought, well, there's a demand there, there's a niche market, or there's an area there that the magazines aren't providing for. So I then turned around and thought up a name for a magazine, because the original name for a magazine was the Australian Experimenter, and I didn't want to use that name. And I just thought up the name Talking Electronics. You know, it's a good play on words. So now I've got a concept, I've got an idea, and I want to do digital circuits, and I've got the name of the magazine, so it all came together, and I sat down for about 3 months and started writing articles for a magazine. The whole magazine, I did everything. Well, you couldn't employ people because they didn't even know how to do layouts for magazines in those days, and of course they were expensive, and if you get a person full-time, well, I didn't know it was going to be terribly successful, I had no idea. So the only thing I could do was to write everything myself, and to get a typewriter, and I put everything on a typewriter and to type the thing out. I could get a typeset by someone. Well, it wasn't typeset, it was actually just typed out on an electronic typewriter or electric typewriter. And for the first magazine, it was just done on a typewriter at no expense, or very little expense to me. I just bought a golf ball machine and just typed it out myself and laid everything out myself. I got pages from the printer, were layout sheets, and put everything down with cow gum, that horrible sticky gooey stuff, and laid everything out and stuck everything down, and even every single item was all stuck down in little tiny pieces, and everything was ready for them to print. I'm not a good artist, so some of the magazines I had, or books I had, I cut out some of the odd pictures of things so that I couldn't copy myself, and the circuit diagrams I just did it myself with a pen, an Indian ink, and with Letraset. I used to use a lot of Letraset, but even though Letraset was they didn't have the symbols I wanted. They had the letters R and the Omega sign and a few other things which I used initially, but they didn't have the symbols I wanted, so I had to sort of draw all those myself. But it was all done by hand. I brought the first one out, and it was such a huge success that I was absolutely flat out, because I only had one. I employed somebody. I employed my first employee. I had the magazine, and I was busy. I didn't have time to write the second magazine for about 2 or 3 months. It was so busy every day, answering the phone for orders, by mail. I got more orders, and of course people started to come around to buy the kits from my own home. So I had no time at all to even start to write the second magazine. I had already articles there, but I didn't have any spare time to really sit down and really set the magazine and set it up for about 2 or 3 months. When things started to slow down a bit, I had a bit of free time to write the next issue of the magazine. So I don't know how someone like Leo Simpson can write a magazine every month. It's an enormous amount of work. Electronics is absolutely enormous, and it's getting even bigger now. But even in those days, to learn just one, and that was my whole field, was just to teach a very narrow area. I didn't teach RF, I didn't teach communications. It was just to do with just making a LED flash, something very, very simple. It was about 1981, at the time when computers had just barely come in. But computers to teach anything, or to actually build a computer, it still hadn't come in. So it really was in the days that digital had just come in. Transistors and the chip had just arrived. Just before the magazine, the only digital device that was available was called a Norbert from Philips, and it consisted of a couple of OC44 or OC71 transistors and a few resistors inside an aluminium casing, and all it did, it had about 12 leads coming out of it, and you had to figure out what lead did what, and it was purely an AND gate or a NOR gate or an OR gate or something like that. And then straight after that we got the very first digital chips, CD4011, 4001, and this was the beginning of the digital era. I produced a number of issues, and then I was playing around with a tiny little circuit, a little transmitting circuit, and I just jumbled a few wires together, and this was the final FM bug, a little tiny FM bug. So I went to the radio in the next room, turned it on, and I could hear the staff in the other room as clear as a bell talking. And I was absolutely amazed that it transmitted about 20 metres to a radio, and as clear as anything. So I thought that this is unbelievable. So I went back to the circuit, and I had left off a wire to the antenna. So when I put the wire back onto the antenna and I went back to the radio, it was still just as clear, but I was able to get a small FM radio and go not only out the front door, but down the street about 2 or 3 houses. And I thought that was absolutely amazing, to go about 100 metres before it only went to the radio, and it was a little bit noisy. But when I actually connected the antenna, it was absolutely magnificent. It was as perfect as an FM radio station. It was my design, that's right. I improved on a very poor design that I picked up. So I improved on the design, and I produced a separate book from the magazine called FM Bugs. And I thought, well, what a good idea to put a printed circuit board on the front. That would sort of promote things. Well, it just took off. It just absolutely snowballed, because now people can had the printed circuit board for less than $10. They could buy the whole kit. And we sold 30,000 of these FM Bugs. It was absolutely enormous. That's the way it started, with these printed circuit boards on the front of the magazine. With the FM Bugs, there was just so many variations. We produced a voice-operated one, and of course then we finished up putting some on the telephone line. Very simple device, went on the phone line, and of course, because we sold the FM Bugs to the police as well. because the bugs that they had were noisy and you couldn't understand them and they were terrible. Of course, ours were very cheap, and of course you knew who a policeman was, the way he acted. He came and bought the thing, you wouldn't see him again. But of course our bugs were found in the St Kilda police station, and they bought one for the telephone line. And of course they were furious. The whole government was furious. And of course they saw the PC board, knew where it came from, and of course they raided us. Not only did we get federal police, we got tax inspectors and local police coming around raiding the whole place because of these interception devices. And of course there was court cases over it, cost us a fortune. So it was a real headache. It was only when it was attached to a telephone line. It was interception of the telephone line was the criminal charge. And of course I never put one on, but the wording of the court case was changed to enabling somebody to intercept a conversation. I didn't have to do it myself as long as I assisted, not even assisted somebody, but the word was enable somebody. And they've changed the law to actually sell the device, not only made up, but also in kit form. So any bag of parts at all can be turned around, because it only take any number. I can build these bugs on the phone line any way at all. With any of my kits could do it, because they have the same transistors, the same components, so any one of my kits could have been a kit for enabling someone to intercept a phone line. Well, if they caught me the third time, I got 120 years jail. I just stopped producing it, that's all. I sent out, in issue 5, I sent out 2,300 Talking Electronics magazines to every single school in Australia. That was high school, technical school, Catholic school, private school. 2,300 for them to subscribe to the magazine. In the next year, I got 19 replies out of 2,300. It was an enormous loss. I think it was. I think that it was very exciting for people to be able to build something which used a chip and change from the fact that just they used transistors before, and then we got to chips, and it was a concept which was new. In fact, all the circuits I designed and everything that I designed myself. They were new, they were novel, they were games, they were little trinkety things, but they were successful. People just wanted to learn to put a few things together, and it did something. It turned the lead on, it made a noise, or it did something. And that was the whole idea, is to build a very cheap project under about $10 or $12. With my magazine, my whole concept was that every project I produced was backed up by a kit. And this was the first time in the world that anyone had done that. And not only that, but I was the first in the world to put a printed circuit board on the outside of the magazine, and the printed circuit board had an overlay, and it had solder mask, and it had tinned solder land. So the board, when it was soldered, it came up perfect. Other thing was this new world of digital things, where you pushed buttons and made something flash. So that was a completely different market that anybody else had tackled. So that was when I started the Talking Electronics, and that was why I was so successful, because that's what other people wanted to do as well. They wanted to make these things something they could take along to school and show in a show and tell or something, and actually did something. They could show everybody else what they'd produced. As soon as the magazine came out, we got an enormous number of orders for a simple magazine, and we just went on and on and on with more projects along those same lines. We also introduced other projects, and as the other projects weren't successful, we didn't go along the amplifier market, we didn't go along the radio market. They weren't nearly as successful as just these projects that made LEDs flash and noises and tones and things. Well, the 74 series of chips, they were really associated with designing a computer. And the actual digital chips that we dealt with were the CD type chips, which were the purely an AND gate and an OR gate, or an OR gate or an XOR gate. They were the chips used for simple digital projects. Our tech computer from Talking Electronics was a Z80 based, and it was a Z80 chip, and it just used a very small amount of ROM and RAM and a very simple set of 7 segment displays and a very simple 20 key keypad with hexadecimal keys on it, just to explain the very basics of how a computer works. And that was we sold a lot of them. We sold over 1,200 of these computers, and the people built them themselves, and they worked. If they didn't work, they could send it in for repair. We got very few sent in. They did work, and out of that, we got quite a number of actual games that people actually wrote for that particular computer, and we published them in issues of the magazine. So that was very successful. We initially started in issue 10 with the computer. And somebody said that the magazine has only got black and white and one colour on the front. If you put full colour, you'll sell more issues. So I put full colour on issue number 10. We sold no more issues. So it was a total waste of money spending the extra hundreds of dollars, another $1,000 on getting colour separations. But we did put the tech computer on the front in full colour, and it sold very well. Right from the very beginning, we were making up 100 at a time, and they were gone in no time. We make up a batch of another 100. So it was a starting point to teach people programming in machine code using the Z80 as the basics of the whole unit. We had a speaker there. You could produce tunes and tones. One of the staff did. He came along one day and said I don't know where he got it from. It could have been someone said it's a slight copy from somewhere else. But the fact is, he knew about computing. He was very, very good. And he made the first prototype for us. We then made a printed circuit board. Then he was actually working for me, but he just came as one of the workers' friends. Then I said to him, "Oh, well, that's beaut. Now, can you sit down and write how it works?" He said, "Oh, I haven't got time. I've got to do my schooling." So I said, "Well, now I've got this computer. I've never used a computer in my life. I had to sit down and design a few very simple games and a few simple things on how to get from the keyboard to get a simple program to run on these displays." So I had to learn Z80 programming, which wasn't hard. There were 700 instructions, but you knew basically what different things did. But it still took me 2 weeks to sit down and learn to code, to produce a simple program. And then, of course, once I got the programs written, I could actually copy them out, put them in the magazine, explain to people how it works, and get the magazine out. Quite a number of people have already said that they got into electronics via that tech computer, and they're still in electronics now. I think the heyday of the 1970s was the absolute peak, because you were able to buy all the most advanced components, integrated circuits, and then of course the chips came in for computers, and you could build something yourself because it wasn't available on the market. And the computer you did buy soon ran out of memory, so you could add certain things to it and you could improve it, because then the Chinese saw that there was a demand for added boards for computers, faster speed, different graphics cards, and of course they turned around and produced the thing, perfected it, made it beautiful, and sold it through the Chinese shops here, through the Chinese importers, at a fraction of the cost that we could buy the components for.